This video is about differentiation with a focus on tangent to the curve. And just for the purposes of illustration of what's going on here, I'm including a function and its graph. So it's a cubic function and it's x cubed minus x squared minus 8x plus 12. So the first thing that I could be asked in relation to the tangent is I could be asked to find the slope of the tangent to f of x at a particular x value. Now, I've already pointed out in previous videos that when you see the word slope, that has a particular meaning. Slope relates directly to differentiation. Slope and derivative are the same thing. So when I'm asked to find the slope of the tangent, what I'm really being asked to find is the derivative of the function. So what we need to find first is f dash x. And I'll find this just by using differentiation by rule. So take a moment here to pause the video and do your differentiation. What is f dash x? So f dash x is 3x squared minus 2x minus 8. Now, this doesn't give me the exact value for the slope, but it allows me to find the slope anywhere along the curve. And in this question, they specifically want me to find the slope at x equals minus 3. So I'm going to evaluate f dash minus 3. And that simply means subbing minus 3 in for x in our derivative in our f dash x. You can go straight to your calculator for this. And in this case, the answer is 25. So what does this mean with reference to our graph? Well, if we look at x equals minus 3 on our graph, we can see that it's at this position here. And so when I'm finding the slope of the tangent to the function, what I'm doing is I'm finding the slope of the function at this instant, at this particular point, and by extension, I'm finding the slope of the tangent that I could draw to the curve at this exact spot. So this particular tangent has a slope of 25. A similar type of question might be find the slope of the tangent to the function fx at the point 1, 4, and I'm still referring to the same function here. Again, the key word here that jumps out is slope. The minute I see slope, I think of the derivative. I already knew what this was. F dash x equals 3x squared minus 2x minus 8. This time, I'm not just being given an x value, I'm being given a full point. But actually, the y part is fairly redundant because when I want to find the slope, all I can sub in is the x part. So really, all I'm concerned with is the x part of this point. I can find the slope at this point by simply substituting 1 into my derivative. And in this case, I get minus 7. Let's just refer to our graph again for a bit of context. I would like to point out that my graph isn't particularly accurate. So the point that I've marked in is meant to represent the point 1, 4. And if I draw in a tangent at that point, I can see that it's sloping down quite steeply, and it's actually sloping down at a rate of minus 7. So minus 7 is the slope of the tangent at that particular point. Remember that a tangent is a line, and that's going to be relevant in this example, example 3. So in example 3, I'm trying to find the equation of the tangent to f of x at the point 1, 4. Now, the point 1, 4 was previously referred to in example 2. We already found the slope of the tangent at that point. Remember, the tangent here is actually a line. So if I want to find the equation of the tangent, what I'm really looking for is the equation of a line. To find the equation of the line, I need two ingredients. I need the slope and I need a point on the line. Well, the slope is the slope at the point 1, 4. And if we look back to example 2, we've already actually calculated that. We already know that our slope is minus 7 at this location. And we're being told a point also, the point 1, 4. And now all I have to do is substitute that information into the formula for the equation of the line. And I can obviously simplify as well. I like to write the equation of my lines as y equals mx plus c. So in this case, this line is y equals minus 7x plus 11. And this is the equation of the tangent that we've drawn here that goes through the point 1, 4.